forth. But first of all, if you have your given that AC and DB bisect one another, and this is point E here, you know that they are divided into congruent parts. But if we're trying to prove AD is parallel to BC, think about that Z that I keep trying to get you guys to trace over. The two angles that we need to be congruent are this angle and this angle. Because if those two angles are congruent, then I have parallel lines. The other option would be going like this, finding these two angles. But either way, you're going to have the triangle on the left and the right, not the top and the bottom. You have to just pick an option and go with it. So I'm going to stick with my first option, just because it's what I saw first. So, is there a question about that? Okay, so the goal is, in order to get parallel lines, before we get parallel lines, we need to have somewhere in our proof 3 congruent statements, then a congruent triangle statement, then we're going to have the parts congruent, which in this case, I need angle ADE to be, or ADB to be congruent to angle BCD. And if that's true, then I can say that AD is parallel BC. Okay, that's the way I'm going to go through this. Yes?
Isn't the angle CBD, not BCD?
Yes, I wrote it wrong, thank you. Kira, was that your question? Thanks. So, should I start? Okay. So, I'm going to go through and say AC and DB bisect one another. It's my first step. And I'm going to just write my proof out. So I know, and then I'll put my reasons in. So that tells me that AE is congruent to EC. And it also tells me that DE is congruent to BE. Get this out of the way. That's just my little side notes. Okay, but I need a third part, so what's the third part? Yeah, Tyler.
Vertical angles.
Yes. So I know that AED and angle BEC are vertical angles from the diagram. Therefore, they're congruent. Now I have my 3 congruent statements. So I can say that my triangles AED and the first letter has to be C. Marissa? I mean, Maddie?
When you're writing your proof, do you have to say AED and BEC are vertical angles?
So that's something that really you see in a very thorough proof. People, so your book is somewhat inconsistent. It's my habit always just to state the angles, what they are from the diagram. I think it slows you down enough to maybe make you remember your steps. Now, if it's a big proof, I'll be really honest with you, and you leave that out, you're not going to lose points. But if, you know, you could go from 2 to 4. But I do think it helps you remember, like, why you do things. So if you look at the corrected stuff, you'll see it both ways. Okay, and I'm going to be honest with you, I would allow you to go to step 4 from step 2. I'm just trying to show you kind of like what they are and then what that means. It's just a habit. So it's just a thorough habit. Before we take the next question, can I get the first letter of the triangle? And then I'll do the, like, what should it be, Ethan? A, E, D. So what goes with A?
C,
C,
E,
E, D. Good. Okay, Kira, what was your question? Tyler, somebody had.
Oh, yeah. I'm just gonna ask, would you recommend the 2-column proofs as the best way to write
I
it?
think it's the way most people are successful.
Yeah.
Easy to read.
Yep.
So now I can say, so are we clear on this? In old books, you saw this all the time. In new books, you don't see it all the time. You see it sometimes. Some people, I think it really helps them to be consistent. So to be consistent with your book, they do both. So I just did it. But it's sort of an optional step. Okay. So now I'm going to say that this is my goal. And you'll see that I'm going to put that in here. ADB is congruent to CBD. So looking back at my picture, that's the way the dots are. BD. And again, another optional statement that you'll see in the old books is that it would state that they're ADB and CBD are alternate interior angles. So parentheses, that's optional. Okay. And then now we know that the lines are parallel because we have congruent alternate interior angles. So we have to go back and fill the reasons in here. So this was a given. This is not a number 2. Numbering's off. That's one sentence. So this was given. Over here you're going to be writing sentences, not a bunch of initials. There are some initials, but you're not going to write segment bisector. You're going to tell me about it. So a bisector divides a segment into 2 congruent parts. And then this right here is given from the diagram. So you can write diagram. And then this here is, we know our conjecture says vertical, so write it out. Vertical angles are congruent. If you just write vertical angles, you're going to lose the point. Tell me what about the vertical angles? Kira?
You can have written ABD through BDC because they're vertical angles as in
Because the vertical angles are congruent. Stay what they are because they're congruent. So the theorem says vertical angles are congruent, so you should say they're congruent. Ethan? Yes, you can use congruent and angles as long as your symbols are neat. If I can't read your printing, you better print slower.
Why not? We say, if we forget to congruent mark, like.
You'll probably lose a half point, right? Don't just tell me the names. I want you to tell me about vertical angles.
So if we say equal by accident, like, forget the.
Okay, yeah. So segments, shapes are congruent. Numbers are equal.
Yeah.
So you should be using congruent symbols. And your book, again, is mostly consistent there. But I'm going to ask you to put congruent marks and bars. So really where you lose the mistakes, if you don't put what things are, like is it a segment, there should be a bar over it. Is it a triangle, there should be a triangle in front of it. Is it an angle, it should be an angle in front of it. If you have like all these congruent markers and one of them becomes an equal, I probably wouldn't take them off. But if it's consistent through your test, you'll get docked. But like, let's say you didn't put one congruent marker on your whole test, I'd dock you on one problem, and then on the other problems, you probably would just see a note, same, because I'm not going to take off points over and over and over for that same mistake. So these, step 5 is by side angle side. Step 6 is the corresponding parts of congruent triangles are congruent. Tomorrow's part of the test, I'm going to ask you to write those out, word for word. So you should be able to state the side angle side conjecture.
Should we number
Um, it helps if you don't have lined paper to number it or just to draw lines. So the reason I'm numbering is so you can see what they go with, right? So you're not going to have lined paper, but you know, you could just, of course, go away. Isn't that funny? It just won't go away. Oh, there we go. Now I don't have a line. But anyway, you could draw lines. But since my lines I could tell were already a little crooked, I numbered them. Does that make sense? So you can see what. And then this is from the diagram that they're alternate interior angles. And then the last step, if the alternate interior angles are congruent, then the lines are parallel. Order matters. So you have to say alternate interior angles are congruent first. No, just saying what kind of angles they are means given from the diagram. That was that optional little step. So remember, stating the type of angles right there. It's what you used to see in every old proof. I think for the way some people think it's still really a nice clarifying step, but I would say it's optional. Your book's a little more modern. So since the alternate interior angles are congruent, we know that the lines are parallel. So I have alternate interior angles congruent. The arrow means implies then, right? It's an if-then statement. If the alternate interior angles are congruent, then you have parallel lines. So that's the proof there. Okay, so on this one, we're looking at this kite. Like I said, the reason they tell you that KE is congruent to ki is, in case they didn't draw a picture, you would draw the proper picture. But since it's a kite, you also know these are congruent, and you also have same segment. So we're going to do side, side, side. Okay, so we have to show that KT bisects angles. So what parts, like Charlotte, what parts do I want to be congruent? What do I need? I mean, obviously I need 3 congruent parts to get congruent triangles, because that's what we're focusing on. And then, what do I need from this picture?
Congruent angles.
What congruent angles?
IKT.
Right, I need angle IKT to be congruent to angle E, IKT to be congruent to EKT. And I also need angle ETK to be congruent to angle ITK. So by doing this to the side, I'm saving myself a lot of erasing because I'm thinking about my plan before I start. And that's how I finish the test on time. Is I planned it out before I write and then realize halfway through the proof I'm going on the wrong tangent. Okay? So now I've got a plan. I know I can do this by side, side, side. If I have this angle equal to this angle, then KT bisects angle IKE. And if I have this angle congruent to this angle, then KT bisects ITE. So I'm just going to write it out. I'm going to say KITE is a kite with KE congruent to KI. And I have to add in, so that's given, right? Then I'm going to have to also say IT is congruent to ET. A kite has 2 distinct pairs of congruent adjacent sides. So now you know why in chapter 1 I was asking you to write these out over and over, because you have to use them in your proofs. So not kite, but you're going to tell me what about the kite, Michael?
You have to say distinct and adjacent.
Yeah, because otherwise they could be a parallelogram, right? That's what makes it a kite.
If you just say kites have 2 sets of congruent sides, that would be adjacent.
2 sets of congruent sides that are adjacent. They're different though. Like so does a rectangle. I mean, so does a square. Distinct. Like a square has adjacent congruent sides, and you can argue there's 2 sets, but they're not different. So that's a step 1, and then step 2, right there. So my third step, this isn't going to be long, so I'm going to just jump down here where I have space. Because now I have this and this, so I need, I just need same segment. KT congruent to KT. And that's the same segment property. So this is an easier proof. Sometimes when it's longer, I don't do the reasons until the end. I just get all my statements, but this is easy enough to go step by step. Then, so there's my third part.
What are the angles that are formed by 2 intersecting lines and collineating?
Linear pair. So you probably won't be using that this week, just to alleviate some things that you have to review. 4, now I have triangle, and we already KIT congruent to triangle KET by side, side, side. So I need the parts, right? So I need this now. Save time, I'm going to pull those over there. And that's congruent, corresponding parts of congruent triangles are congruent. So this first statement tells me that KT bisects which angle? What's the first statement tell me? So KT, in other words, order is important. If this comes first, bisects IKE, yeah. Angle IKE, it's supposed to be an E, and the other one, ETI. Look in the picture, make sure I said that right. Yeah, ETI. So pay attention to order. In other words, this goes with this angle, and this statement goes with this angle. And a little, you know, an angle symbol there. There we go. And so if an angle is divided into two congruent parts, then, so I really should have said if a segment divides an angle into two congruent parts, then it is an angle bisector. I have to scroll down to do that. If a segment divides an angle into two congruent parts, then it is an angle bisector. Look at that. Got some numbers here. This is 6, 5, 4. Just a little bit up here. All right. Does that help?